Hey everybody, welcome to the next chapter, 3.2, Using Algebraic Methods to Solve Linear Systems. Today's objectives, you're going to be able to learn to solve systems of equations by substitution, and you'll be able to solve systems of equation by elimination. So, surprisingly, the vocabulary for today is substitution and elimination. All right, the graph shows a system of linear equations, and as you can see, without the use of technology, determining the solution from the graph is not easy. You see, it doesn't actually hit an exact point. You can use the substitution method to find an exact solution. In substitution, you solve one equation for one variable, and then substitute this expression into the other equation. Let's see how it works. So the first thing we want to do is solve one equation for one variable, if necessary. And in this case, we could see that y is already solved for x equals, says that y equals x minus 1. So all we're going to have to do is just substitute. We'll write x from our next equation, x plus y, and instead of using y, we're going to say x minus 1 equals 7. So that leaves us with 2x, and let's add 1 to both sides. So that would be equals 8. Divide both sides by 2. X equals 4. Okay, so we're almost there now. We've already solved for our x. Now all we have to do is solve for our y. So let's just put it in whichever equation seems easiest. I think y equals x minus 1 is easier, so I'm going to just replace my x with a 4. Y equals 4 minus 1, so y equals 3. And so you write your answer as an ordered pair, 4, 3. And there we see the solution to this system is the ordered pair, 4, 3. All right, and you can also use your calculator to check this if you wish. That's what our next slide shows, a picture of that it would show up like that. And so let's try another one. In this case, solving one equation for one variable isn't quite as easy, but it's almost as easy. So I'm going to choose this one because the x is almost by itself. So I'm going to say 2y plus x equals 4. And I want to solve for x, so I'm going to subtract 2y on both sides, minus 2y. So that leaves me with x equals 4 minus 2y. And so now I'm going to choose my other equation, and I'm going to just substitute my x. Instead of x here, I'm going to write 4 minus 2y. Minus 4y equals 7. So now we just have to distribute our 3, so that's 12 minus 6y minus 4y equals 7. Let's add our like terms together, so that's going to be a negative 10y plus 12 equals 7. Subtract 12 from both sides. We have negative 10y equals negative 5. Divide both sides by negative 10, and we get y equals 1/2. All right, so we're not quite finished yet. Now we're going to substitute our y into one of our equations. So let's choose this equation here. 2y plus x equals 4. So now I'm going to substitute my y that I know. 2 times 1/2 plus x equals 4. 2 times 1/2 is just 1 plus x equals 4. Subtract 1 from both sides. So x equals 3. So our ordered pair is going to be 3, 1/2. And that is the solution for this problem. The solution is the ordered pair, 3, 1/2. And again, you can use your calculator. The next slide is for those of you that would like to put this on pause. If you'd like to have words to do each of the steps, you're welcome to stop the video and write these steps down if you feel like you need that. All right, the next example, use substitution to solve this system of equation. I'd like you to try this one on your own first, so put the video on pause and give it a try. Okay, let's come back. So the first step that we're supposed to do is solve for one variable in at least one equation if necessary. And so I can see already that one variable has already been solved, y equals 2x minus 1. So I'm just going to substitute that in place of my y. So I'm going to say 3x plus 2, and instead of saying y, I'm going to use 2x minus 1. And all of that is going to equal 26. All right, so I have 3x, and then I'm going to distribute my 2. So that's going to be plus 4x, and distribute again, minus 2 equals 26. So I'm going to add my like terms together. 3x plus 4x is 7x. And now I'm going to add 2 to both sides. So that leaves me with 0 there, equals 28. So 7x, 7x equals 28. Divide both sides by 7, so x equals 4. All right, so I'm halfway finished. Now I'm going to substitute again. I'm going to choose this equation. I'm going to say y equals 2x minus 1. And I'm going to substitute y equals 2, and instead of x, I'm going to say 4, because that's what we solved for, minus 1. So y equals 8 minus 1, y equals 7. So my ordered pair is going to be 4, 7. All right? And again, you can use your calculator, and when you put in the numbers, you'll find that it supports your answer. All right. The next thing I want to point out is it really doesn't matter whether you isolate your y or your x. I always just try and figure out which one is easiest, and if I get into one and it has some ugly fractions in it, then I change over to the other. Try isolating if I try the x and that's kind of difficult, then I'll try the y. So I'm just going to show you and do both of them. So first of all, we're going to isolate for y. So I'm going to choose this example because the y is almost already isolated. It just has a negative attached to it. And I am going to go ahead and rewrite it a little bit differently. Negative y equals 2x minus 2. And so I just need to divide everything by a negative 1. And that leaves me with y equals negative 2x plus 1. Okay. What did I do wrong on that? Oh, I know, that's not a 1, that's a 2. That was wrong. 2x plus 2. All right, so now we're going to substitute my y into this next equation. So I'm going to say 5x plus 6 times my y, which is negative 2x plus 2, equals negative 9. All right, and this was supposed to be a 6 here. Okay, so I have 5x, and I'm going to distribute my 6 to both sides, plus negative 12x, and then distribute it to that, plus 12 equals negative 9. All right, so when I put my like terms together, I end up with negative 7x, and let's subtract 12 from both sides, minus 12, equals a negative 21. All right, dividing by negative 7 on both sides, we end up with x equals 3. Okay, so let's just resubstitute now. Let's use our other equation. 2x minus 2 equals negative y. So let's fill in with our 3. So 2 times 3 is 6 minus 2 equals negative y. So this tells me that 4, I have to come over here, equals negative y. So y equals negative 4. Okay, so here the solution set when I isolated for y was x equals 3 and y equals negative 4. 3, negative 4. Okay, so now we're going to do isolate for x, and you're going to see this one's a little bit messier, so let's just give it a try. So again, I'm going to isolate x. So I'm going to say, I'm going to start with the one that seems a little easier to me, and that would be 2x minus 2 equals negative y. And we're going to isolate x, so let's add 2 to both sides. So we have 2x equals negative y plus 2. All right. The next thing I want to do is divide 2 by everything. And now I have x isolated. X equals negative 1/2 y plus 1. All right, so now we got to substitute it into our other equation right here. So we're going to say 5 times negative 1/2 y plus 1 plus 6y equals negative 9. Okay, so we end up with negative 5 over 2y plus, distribute that, is 5 plus 6y equals negative 9. All right, I'm going to go ahead and move my 5 over to both sides. So now I end up with, we're going to just say that is negative 14 right now. All right, so we have a negative 5 over 2y and a 6y. And I know I need a common denominator before I can just add those. So I know I'm going to have a common denominator of 2. Negative 5 over 2y plus 12 over 2y equals 7 over 2y equals 14. So here we have so far 7 over 2y equals negative 14. I'm kind of running out of space here. All right, so I'm going to erase all this, take advantage of this space. Okay, so let's multiply by our reciprocal, which would be 2 over 7 times 2 over 7. So this goes away, leaving us with y equals 2 times 2 is negative 4. So there's our y equals negative 4. That matched up. So now we're just going to substitute in again. Let's use this 2x minus 2. So 2x minus 2 equals negative 4, which is our y. The negative of a negative is a positive, so we have 2x minus 2 equals 4. Add 2 to both sides. That gives us 2x equals 6 and x equals 3. So once again, our ordered pair is 3, negative 4. All right, and you're going to see if we have any room here. There we go. The solution is the ordered pair 3, negative 4. All right. So you can also solve system of equations with the elimination method. The elimination, you get rid of one of the variables by adding or subtracting equations. You may have to multiply one or both equations by a number to create variable terms that can be eliminated. All right, so the elimination method is sometimes called the addition method or linear combination. So let's give these a try. So use elimination to solve the system of equations. So what we're going to do is we are going to get rid of one of the variables by adding or subtracting the whole system together. So what we're going to do is just add the systems together. And when we look right here, if I have a 2y and I subtract 2y from it, that's going to totally get rid of it because we know 2y minus 2y is 0. So let's just add these together. We end up getting 7x plus 0 equals negative 14. All right, so now we just have 7x equals negative 14, and now we can easily solve. So x equals negative 2. Now be really careful because it's always so tempting to say, oh, I'm through, but we haven't solved for y yet. So we need to go back and just solve for y. 3x plus 2y equals 4. So let's substitute for x negative 2. So 3 times negative 2 plus 2y equals 4. So we have negative 6 plus 2y equals 4 plus 6 to both sides. So 2y equals 10, and we can see that y will equal 5. All right, So our solution set is going to be 2, negative 2, 5. And there it is. Okay, next, let's try another one. Now this time we're going to have to, when we look at this, we don't see anything that's quite as readily subtracting. So what we're going to have to do is multiply something on the top and something on the bottom so I get a coefficient that's going to subtract out to 0 when I add them together. That sounded kind of funny. Add the opposites of them. So I'm going to look at this and I see a 3 and a 2, and those are relatively small numbers. So what I'm going to do is I'm going to multiply the top, everything on the top by a negative 2, and I'm going to multiply everything on the bottom by a positive 3. All right, and I always go ahead and write my numbers above each thing, each coefficient here. So I know to multiply everything on the top by the same thing and everything on the bottom, and that will keep it all equal. So let's go ahead and do that. Negative 2 times 3 is going to be negative 6x plus negative 2 times 5 is a negative 10y equals negative 2 times 16, negative 32. And actually that's a negative and a negative, that makes it a positive. All right, in our second equation we're going to multiply everything by 3. 3 times 2 is 6x plus 3 times 3 is 9y equals 3 times negative 9 is negative 27. Now, when I add my two systems together, you can see I have a negative 6 and a positive 6, and those add together to equal 0. Plus, negative 10 plus 9 is a negative 1, not y, equals 32, take away 27, 5. So I can see if I divide both sides by negative 1, y equals negative 5. Now the hard part's done, and all I have to do is just substitute now. And I guess I'll just substitute this one, and numbers seem a little bit smaller. So I'm going to say 2x plus 3 times negative 5 equals negative 9. All right, and so 2x plus negative 15 equals negative 9. And so add 15 to both sides. And we get 2x equals 6, and so x equals 3. And I think I had a negative in there. Let's see, do I? Nope, that's fine. So here's my 2 points, 3, negative 5. And that's the solution to this system. So there it is. The solution to this ordered pair is 3, negative 5. All right, so once you try this one on your own, turn the video off for just a minute and give it a try. Okay, welcome back. So the first one is relatively easy because we can see right away when I add my two equations together, 7x and a negative 7x equals 0. So I just have 4 plus a negative 12x is a negative 8x equals, and negative 25 plus 19 is negative 6. So I'm going to divide both sides by negative 8. I end up with x equals positive 3 over 4. 2 goes into both of those. All right, so now I have my x. So now all I have to do is now I can substitute, and I'm just going to use this equation here. 4 times x is going to be 3/4 plus 7y equals negative 25. All right, so these cross out, so I end up with 3 plus 7y equals negative 25. Subtract 3 from both sides. That equals negative 28. 7y equals negative 28. Divide both sides by 7. Y equals negative 4. So my solution set is 3/4, negative 4. And there it is. All right. Here's one more for you to try on your own. It's a little more challenging, so I really want to encourage you to try this one on your own before just letting it pass on. Okay, hope that you were able to give that a try and get it on your own. What I would do on this one is I'm looking at it and I see the smallest two numbers are a 3 and a 5. So I'm going to use those to be what I am going to try and eliminate first. So I'm going to multiply this, and I've already got a minus and a plus, so I can multiply both of these by a positive number. So I'm going to multiply everything on the top by 5. And so that's going to be 25x minus 15y equals 42 times 5 is 210. And then I'm going to multiply everything on the bottom by 3. So 8 times 3 is 24x plus, here I have my 15y, equals 3 times 28 is 84. All right, so far so good. I hope you're all getting that. So 25 plus 24 is 49x, and our positive and negative y's go away, and then that just leaves us with 294. And amazingly, when we divide 49 by both of them, it comes out even to x equals 6. So now that I've done that, I can just substitute into either one of these, and I guess I'm going to choose the top one. It's a little bit smaller numbers. 5 times 6 minus 3y equals 42. So that's 30 minus 3y equals 42. I'm going to subtract 30 from both sides. So I have negative 3y equals positive 12. Let's see. And divide both sides by 3, by negative 3. And that would be y equals negative 4. And let's see, I think I might have missed a negative sign somewhere. Or maybe I missed a negative sign when I was working it out. So our solution would be 6, negative 4. I'm not going to spend a lot of time trying to find my negative mistake in there somewhere, but should have been 6, positive 4. All right, let's keep on going. All right, in lesson 1, you learned that systems may have infinitely many or no solutions. When you try to solve these systems algebraically, the result will be an identity or a contradiction. So remember, an identity such as 0 equals 0 is always true and indicates infinitely many solutions. All right? A contradiction such as 1 equals 3 is never true and indicates no solution. All right, that's really important to remember. 0, 0 means infinitely many solutions. So let's give it a try. Okay, so it says classify the system and determine the number of solutions. And I'm actually going to just kind of zip through this pretty fast because I just want to get to the end. So if we were, when we go through and solve, because isolating y is pretty straightforward, we would use the substitution method because they already have y by itself. So all we have to do is isolate y, and y equals 1 minus 3x. Just subtract 3x from both sides. And then you're going to substitute this 1 minus 3x back into an equation and distribute and simplify, and here's the part that I wanted to get to. All right, so it says 2 equals negative 18, and that is not true. 2 will never equal negative 18, so the equation is a contradiction. Okay, therefore the system is inconsistent and has no solution. All right, let's try another one. Again, we're going to have to solve this first, and when you get started solving it, again, you can see this y is almost all by itself, so we can isolate the y and substitute. And you can go back and work through these problems if you'd like. I just really want to get to the end of the punch line here. So when we keep on and go ahead and simplify, we actually end up, I want you to look here, after we distribute everything, we have 56x minus 56x. So these actually turn to zeros, and all we end up with is 32, negative 32 equals negative 32. And that is a true statement. Okay, so this equation is an identity. The system is consistent, dependent, and has infinite number of solutions. And you can look at this one, and if we divided 7, the whole thing by, I'm sorry, if we divide the whole thing by 8, you actually realize that it's the exact same line. 56 divided by 8 is 7 plus 1y equals negative 4. So it's actually the same line. So every number you put in is going to be true for both equations. And finally, one more. I'm not going to make you do this on your own, just you can watch through it. Again, if you need to isolate the y, and if you're struggling with these, you can go through and take this really slow, and you can check to see if your answers are the same here. Anyway, you want to isolate your y because that's going to be the easiest, and then substitute. And really, sometimes it's easier to substitute, and sometimes it's easier for elimination. I want you to know how to do both, but in the end, you can just choose whichever one works out easier. And there's almost always an easier way. All right, again, notice after we work it all out, 6x and negative 6x cancel out, leaving us with negative 18 equals negative 12. That is never going to be true, so the equation is a contradiction. Therefore, the system is inconsistent and has no solution. It will never have a solution. Okay, so let's do a practice problem. It says a veterinarian needs 600 pounds of dog food that is 15% protein. He will combine a beef mix that is 18% protein with a bacon mix that is 9% protein. How many pounds of each does he need to make a 15% protein mixture? All right, so let's talk about what we're going to do here. First of all, we're going to need to make two equations, okay? And the first one, we're going to just let x represent the amount of beef mixture in the mixture. All right, so for this one, we're going to let x equal the beef, and we're going to let y present the amount of bacon in the mixture. Okay, so what we know is beef, which we're going to say is x, plus bacon, which we'll say is y, is going to equal 60 pounds. Well, he needs 60 pounds of dog food, so the dog food is going to be made up of bacon and beef, and in the end we're going to have 60 pounds of dog food. All right, we know that the dog food is 15% protein, and he will combine beef mixture that is 18%, so let's say 0.18x, and he's going to have a bacon mix that is 9%, so we're going to call that plus 0.9%, and those two added up together, we want that to equal 9% protein. All right, let's see, how many pounds of each does he need to make? So so now that we have our two equations set up, we're going to get going. All right. So we're going to have our two equations, and we're going to solve. Here they are. We have two equations to solve, and what we want to do is, again, we can choose either way, substitution or elimination. And I'm going to go ahead and choose substitution because I can see that that's going to be much easier. So I'm just going to say subtract y from both sides. I'm going to say x equal 60 minus y. All right, now the next thing I'm going to do is I'm going to make my math a little bit easier. I don't like working with decimals, so I'm going to multiply everything by 100. So I'm going to move my decimal place 2 points over on everything. So I'm going to actually end up with 18x plus 9y equals 900. Okay, so once I've done that, now I'm going to substitute in to here. I'm going to say 18 times my x is 60 minus y plus my 9y equals 900. Okay, and when I distribute my 18 to 60, 18 times 60 is 1080 minus 18y plus 9y equals 900. All right, so I'm going to put all my like terms together. Negative 18y plus positive 9y is negative 9y. And I'm going to go ahead and subtract from both sides. And when I do that, I end up with 180. 180. All right, let's see. So I have negative 9y equals 180. Divide both sides by negative 9. Oops, that was supposed to be a negative there. By negative 9, so I end up with y equals 20. All right, so I'm almost there, and I'm going to choose the easier equation to put that in. X plus 20 equals 60. Subtract 20 from both sides. So I have x equals 40. So I know that I'm going to need 40 pounds of beef mix and 20 pounds of bacon mix. All right, let's move on. One more. Why don't you turn the video off for just a minute and see if you can do this one on your own. It's really important that you learn how to do them on your own. All right, so here we go. It says a coffee blend contains Sumatra beans, which cost $5 a pound, and Kona beans, which cost $13 a pound. If the blend costs $10 a pound, how much of each type of coffee is in 50 pounds of the blend? All right, so here we go. We're going to let X represent the Sumatra beans, and we're going to let Y equal the Kona beans. So our first equation is just going to be X plus Y, the Sumatra beans and the Kona beans, and that has to equal 50 because we're going to want 50 pounds in there. All right. The second equation is the cost. So we're going to say 5 times the X, which is the Sumatra beans, okay, plus, and the Kona beans is $13 a pound. All right, and that's going to equal 50 pounds, but we know that it's $10 for 1 pound, and we want 50, so that's going to be how much it's going to actually cost us. So it's going to be $500. All right, and so we are going to say we have x plus y equals 50, and 5x plus 13y is going to equal 500. All right, so let's go ahead and work out this problem. Here's our two equations, and once again, I'm going to choose substitution method because I can see that this first equation is already almost perfect for me. So I'm going to go ahead and say x plus y equals 50, and I'm going to solve for one variable. So I'm going to go ahead and say x equals 50 minus y. All right, so now I just have to substitute 5 times 50 minus y plus 13y equals 500. All right, and then when I distribute, I get 250. 5 times 50 is 250 minus 5y plus 13y equals 500. Let's subtract 250 from both sides. And I get negative 5 plus positive 13 is positive 8y equals 250. Divide both sides by 8, and I get y equals, actually, let's see, y equals 31.25. Okay, So once I have done solve for my y, it's pretty easy to go back now and say x plus 31.25 equals 50. Subtract 31.25 from both sides. And I end up with x equals 18.75. All right. So we have one more equation. Actually, that's all. We have finished. The mixture will contain 8.75 of the Sumatra beans and 31.25 of the Kona beans. All right, and so I'm sure that our math class today was God's favorite subject of all, because we talked about substitution. And on the cross, Jesus took the punishment we deserved for our sin. He did not deserve to die, but he willingly took our place and experienced death for us. Jesus' death was a substitution, the righteous for the unrighteous, the innocent for the guilty, the perfect for the corrupt. So I'm sure this was his favorite. Behold the Lamb of God who takes away, eliminates the sins of the world. All right, I hope you enjoyed your lesson, and I will see you soon.